The objective of this video is that students will find the area of regular polygons. So first we'll start off with some vocabulary. The center of a polygon is just the center of its circumscribed circle. So in this case, the point G would be the center of the polygon as well as the center of the circle. The radius of the polygon is the same as the radius of its circumscribed circle. So in our picture here, there are multiple radii we could look at. GF here is a radius. GE, I could draw radii, several radii here. So two of them that were already in the picture were GF and GE. The apothem of a polygon is the distance from the center to the side. The distance from the center to the side. So if I look at the figure, GH here is the apothem. And then find the central angle is the angle formed by two consecutive radii. So if I look at my figure, I have a number of central angles. AGF, for instance, would be a central angle. FGE would be a central angle. BGE would be a central angle, etc. Okay, and so if I look at this particular figure, I can see that I have 6 central angles. So the number of central angles is going to equal the number of sides. Okay, so looking at example 1, in the diagram, ABCDEF is a regular hexagon inscribed in circle G. Find each angle measure. So first we're looking at angle EGF. So that would be this angle here. It's a hexagon, so that means that I am taking the total of 360 and it's being cut into 6 pieces. So each of the central angles would have to be 60 degrees. So that yellow angle there is 60 degrees. All right, next we're going to look at angle EGH. So EGH is this angle. Basically, when I drew the apothem, I cut that central angle in half. So it's just going to be 60 divided by 2, or 30 degrees. So my blue angle is 30 degrees. And then finally, they want me to find the measure of angle HEG. So HEG is here. And so basically I already know that this is 30 degrees up here, and then they told me that angle GHE was a right angle, so that leaves 60 degrees left over for angle HEG. So again, if you want to figure out the central angle, it's just going to equal 360 divided by the number of sides. Okay, so you want to remember that. Central angle is equal to 360 divided by the number of sides. All right, so suppose I have a hexagon and I want to find its area. And all that I know is that the sides are, let's say, 8 units long. We'll say 8 inches long. It's regular, so all of the sides would be 8 inches. Well, what I could do is I could just break it up into triangles by drawing all the radii. So I've got my center, and then I'll just draw all the triangles. So there's 6 sides, I end up with 6 triangles. So I know that a central angle is going to be 60 degrees, because 360 divided by 6 is 60 degrees. So that's going to be true for all of them. Now, if I could just find the area of one of these triangles, say I'll find the area of this bottom triangle. If I can find the area of that triangle, then I can find the area of the hexagon simply by multiplying by how many triangles there are, in this case 6. So I'm going to go ahead and take this triangle over here and draw it. Okay, so if I draw the height of that triangle, I just split that 60 degrees in half, and so the top angle is 30, and then this angle is 60. So I have a 30, 60, 90 triangle. So if the sides are 8 inches, when I drew that altitude, I cut this in half, so that's 4. That's my short leg, and so my height is my long leg, so it's 4 root 3. And then the side of the triangle would be 8, but I don't need that actually to find the area. So the area of that triangle is 1/2 base times height. And so it would be half, the full base would be 8, and the height is 4 root 3. And so the area of one triangle is 4 times root 3, or 16 root 3. So if I want to know the area of the hexagon, there are 6 triangles, so it's just going to be 6 times 16 root 3. And so the area of the hexagon would equal 96 root 3, or approximately 166.3 inches squared. So whenever you have a regular polygon, you can always find the area of that polygon by breaking it down into triangles and finding the area of one of the triangles. So basically, when we add all the triangles together, what we can do is we can add all the bases together and just do it in one step. So if you prefer, you can always use the triangle method, but if you prefer, you can also use this formula. The area of a regular polygon is 1/2 the perimeter times the apothem. The P stands for perimeter, and the A stands for the apothem. So this distance here from the center of the side is the apothem. Well, that's just the height of my triangle, and the perimeter is just all my bases added together. So it's basically drawn from the area of a triangle. So we can use this method if we want to also to find the area of a polygon. So if we look at example 2, we're going to use 1/2 PA. So first I'm going to find the perimeter. So in this figure, I can see that each of the sides is 3 centimeters long, and it's an octagon, so there are 8 sides. So 8 times the 3 centimeters means that my perimeter is 24 centimeters. Next, I need to find the apothem. And in this case, I can use the Pythagorean theorem because when I draw it here, I already know that the side was 3. When I draw the apothem, I cut that in half, and this side is 1.5. So I've got 2 out of 3 sides on my right triangle, so I can just use the Pythagorean theorem. A squared plus b squared equals c squared. So in this case, I don't know my apothem, and my other leg is 1.5, and that's going to equal c, which is 3.92 squared. So 1.5 squared comes out to 2.25, and 3.92 squared comes out to 15.3664. So if I subtract that, I get a squared is equal to 13.1164. I take the square root, and now I found that the apothem is 3.62. So now I can just find the area using area equals 1/2 PA. So 1/2, the perimeter of 24, and the apothem of 3.62. And so I find that my area is equal to 43.5 centimeters squared. So one thing to keep in mind is that you're going to see some of your special right triangles in these. Like that hexagon, we had 30, 60, 90 triangles. So 30, 60, 90 triangles are going to show up when you have hexagons, but they can also show up when you do equilateral triangles. And then you're also going to run into 45, 45, 90 triangles when you're finding the area of a square. So that's just something to keep in mind. If you don't have a special right triangle and you don't know at least 2 of the 3 sides, in other words, you can't use the Pythagorean theorem, then what's left? Well, what happens is we end up having to use our trig ratios. So in example 3, we're going to have to use our trig ratios to find the apothem. All right, so here I've got a regular nonagon, that is inscribed in a circle with a radius of 5 units. And we're going to find the perimeter P and the area of the nonagon. So first, I need to figure out my central angle. So my central angle is just going to be 360 divided by the 9 sides. And so the central angle in this case would be 40 degrees. So if I just redraw my triangle over here, my top angle is 40 degrees. When I draw the apothem, I cut that 40 in half, and now I have 20 degrees. So for now, I am only looking at this triangle here. All right, so the radius was 5, so I know this side of my triangle is 5, and the apothem is right here. So in order to find my apothem, I have, well, before we find the apothem, we're going to find the side, sorry. All right, so I'm going to find half of the side first, which I'll call x. All right, so now for that one, I have the opposite and the hypotenuse, and so that's going to be sine. So I know that the sine of 20 degrees is the opposite over hypotenuse, so x over 5. And then to get the x alone, I multiply both sides by 5. And so x is 5 times the sine of 20. And that comes out to approximately 1.71. So to find the length of the side, I need to double that. So that would be 3.42. And then the perimeter, there are 9 sides times a side of 3.42. And so the perimeter would come out to 30.78 units. All right, now I'm going to find the apothem. So now looking at the apothem is adjacent, and I have the hypotenuse. For that one, I'm going to use the cosine. So the cosine of 20 is going to be a over 5. And then I multiply both sides by 5 again. And so the apothem is equal to 5 times the cosine of 20. And that comes out to approximately 4.70 units. So now I have my perimeter and my apothem. So to find the area, I just plug it into the formula. Area equals 1/2 PA. So the area of my nonagon is going to be 1/2. My perimeter of 30.78 times my apothem of 4.70. And so when I multiply those, I get that the area is approximately 72.3 units squared. So when you can't use special right triangles and you can't use the Pythagorean theorem, then you'll have to use your sine, cosine, and tangent. And so that concludes this video. Thank you.